Hello everyone, today we are going to develop a web scraping based advanced chatbot with the help of machine learning, beautiful soap and request library. We are going to write the complete code in Python. So if you do not have your Jupyter notebooks open, start opening it, right? So the first thing that you need to do is you need to go into your command prompt. So for me it is Anaconda prompt, and then you can activate your environment by writing conda activate and later your environment. And from that environment what you can do is you can just open up your Jupyter notebook just like this. So I already have this opened, so let's me show you that, right? So there we go, this is the Jupyter notebook that I have already opened, and now let's start inputting the libraries that we are going to need, right? So before doing that, let's actually once see what we are going to do in this project. So we are going to take in a web page from Wikipedia, right? And we are going to use request library to get the data out of it. Then we are going to use beautiful soap to get the data into our Jupyter notebook. And later we are going to convert that into paragraphs. And after that we are going to get the sentences and words with the help of tokenizer. And later we are going to perform word lemmatization, which will help us develop simple form of words. And after that we are going to develop a greeting based system, and at the end we are going to have a perfect chatbot for us, right? So let's get it started. Let's see what happens and how we can develop this chatbot. So the first thing that we are going to need are the libraries. The libraries that we are going to use in this program are NLTK. Other than that, we are going to use NumPy. So if you do not have any of these installed, please write pip install and then the name of the library right here, right? You can also do that from your command prompt as well. And then we are going to use random. After that we are going to use string. Other than that we are going to use beautiful soap. So I have already installed it. Its name is bs4, right? And let's import bs4 as bs, which is beautiful soap. And after that let's import the request library, which is available in url lib. So url lib dot request, and at the end let's actually import the last library, which is re. So we are going to perform substitution with the help of this library. Now that we have installed all the library, what is the next step? The next step is actually to take in the data, right? So let's say that link is equal to url lib dot request. After that we are going to write dot url open, right? So this is the command that we are going to use, and in this I am going to enter the web page that I am going to use. The web page that I have selected is the data science web page of Wikipedia. So let me show you that web page as well. So what we are going to do is we are going to take the data that is available on this page, and we are going to ask the questions from this page and see if our chatbot is good enough to answer them. So let's start that, right? And after putting in the link, the next step is actually to read the link. So for that we have to use the read command. For that let's write link is equal to link dot read. There we go. After that we have to get the data out of this, right? So after reading it, the data can be taken out with the help of a library such as beautiful soap, and for that we are going to use bs. So let's write data is equal to bs dot beautiful soap is the module name that we are going to use. So let's write beautiful soap, and after that I will just write that link should be given here, and rather than link, we are going to tell it the format, and the format is LXML. So let's write LXML here. So there we go. This is the command with the help of which we are going to get our data right here. So let's see what our data is. So this is the complete data, right, from the web page. So what do we want to change in this data? The first thing we need to have is the paragraph, right? So for that, we can get out the paragraphs by seeing where is P available. So for all the Wikipedia data, there is always a P for paragraph. So for that, let's do data dot find underscore all, and here I'm going to write P. Let's do that, right? And what is the next step? The next step is to actually get out the complete text of the data and make sure that it is in the lower format, right? So for that, the first thing that I am going to do is I am going to take data text as an empty variable, and after that, what I am going to do is I am going to check if, with the help of a for loop, if there is anything available in the data paragraphs, right? So for para in data underscore paragraphs. So until the end of this video, you will be very much familiarized what are chatbots and how a simple chatbot can be developed with the help of machine learning, right? So here I am going to write that you should enter all of the data into the data text, right? So everything that is available in para.text will be shifted on into that data underscore text, right? And it will be incremented, and all everything will be given into data underscore text, right? So let's see that first, and after that, let's see what is data.text. So chatbots are very important, of course. If you know that, that's why you have clicked on this video, right? And learning to develop chatbots with the help of techniques such as machine learning, deep learning, and also state-of-the-art techniques like Rasa, OpenAI, or even Amazon. These are very important things nowadays. Every industry and everyone needs chatbots, right? So this is a basic project with NLTK, but I will be doing more projects with the help of deep learning and other techniques as well. So this is data text, right? And after this data text, what we need to do is we need to actually convert it into the lower format. So let's do that. Data underscore text is equal to data underscore text dot lower. There we go. So with the help of this, it will be converted into lower format, right? So then there will be no words such as this one, or bigger N or B or something like that, right? So we are doing that because it helps a lot in tokenization. When the data is in the form of only one type of syllables, if it is small letters, then it is very helpful, right? Now what is the next step? As you can see, there are a lot of square brackets and 19 and 15 and all of these numbers present in the data, right? And other than that, there are these slash n and these things as well. So what we are going to do now is we are going to use the RE module that we imported in the start to remove all of these values, right? So re.sub is the command. With the help of this command, what we can do is we can actually delete these things or replace them with some other string, and the string that we are going to replace it with is a space. So for that, what I'm going to do is I'm going to write data.text is equal to re.sub, and after that I'm going to tell it that you should focus on the words from 0 to 9, right? So r and then string sign, right? And after that I'll put in a slash, and after this slash I'll tell it you should focus from 0 to 9. So let's do that. 0 to 9, these are all the words that will be shifted, and then there is a static as well, right? For that, let's write static, and later we have another slash, and this is how we can shift it just by saying that convert this complete string, right? So for that, let's write this, and after that what we are going to do is we are going to tell it what should we change it with. So we are going to change it with the space. So for that, let's do this, right? And where do we want to do these changes? We want to do these changes into data underscore text. So this is how all the 0 to 9, all the words and static, all of these will be changed. This complete, I'm talking about this, right, with the space. So all of this will be deleted. If it is between 0 to 9 and in this square bracket, all of this will be deleted and shifted with a space. So what is the next part? The next step is actually to also replace these slash and these things, right? So for that, what we need to do is we need to use another substitute command for them. So this is the command, right? So it will be slash s plus, which means that slash n, and it will be changed with a space as well. So now let's do that. After that, let's also print out data underscore text, and this is your new data. As you can see, it looks like it is in a very better format than before, right? So it also can be said and presumed that now this data is usable for our work, right? So then let's start developing the chatbot for real. Now, what is the next step? Now that we are done with data analysis, the next step is to actually perform tokenization, right? So we are going to make the sentences and the words out of the data, right? So for that, sentences is equal to scn, and let's say scn is equal to NLTK, and the tokenization library for sentences is SENT underscore tokenize, and here I'll input the data underscore text. Other than that, we can also do the same thing with words, right? So words is equal to NLTK dot word underscore tokenize, and we are going to input data underscore text in this as well. So there we go. After that, we will have our sentences and our words. So let's see how they are looking, right? So these are the sentences. This is the first sentence, this is the second sentence, then the third, then the fourth, then the fifth, and all of these sentences are now separate and not in the form of a complete paragraph type situation. In the same way, we can also see words so that we know how our words are looking as well, right? So as you can see, sentences are in a very good form and words are actually also in a very good form, right? So we have some words like this, commas and these, and a, but other than that, words are in a very good form, right? And after that, now we have both words and sentences, right? So until now, what we have done is we have taken a web page and we have scrapped the data out of that web page with the help of beautiful soap as well as request library, and after that we have made a paragraph out of it, and then we have divided it into multiple paragraphs, right? And after dividing it into multiple paragraphs, we have exchanged the characters that were not needed, and later we tokenized the words as well as sentences, right? And now we have this words and sentences. So what is the next part? If any one of you is familiarized with NLP and chatbot development, you will know that next step is something like using a lematizer. What does a lematizer do? It converts the words into simple format. So for that, what I'm going to do is I'm going to take in the WordNet lematizer. What will the WordNet lematizer do? Let me show you. So basically, a WordNet lematizer is available in NLTK, right? And this takes in different type of words like dogs, churches, and a back key and these things, right? And all of these words are converted into a word that is more logical, like dogs are converted into dog, and if there is doggy, it will be converted into dog as well, right? And if there is churches, then it is converted to church, right? And if there is a word whose spelling are not looking good, then they will also convert that as well, right? Other than that, there are a lot of words that cannot be changed, like rock or hard rock or werewolf or things like that. So this is the main concept of lematizer, to use it to make the words much simpler, and the reason for that is to make sure that our bot can later recognize those words easily, right? So this is the main step, and it is available is NLT in NLTK corpus. So if any word is not available in this complete word net, then that word will be returned as a same word. So let's do that. Let's make the lematizer. Now let's write WN LEM, lematizer is equal to NLTK dot stem, and after that I'll write dot word net lematizer. So there we go, and this is a function. Let's write this as well. So now that we have the lematizer with us, what is the next step? The next step is to perform lemmatization. For that, let's define a function which will say that perform LEMM, lemmatization, right? And it will take in tokens as input and perform the lemmatization, right? So for that, what I'm going to do is I'm going to use the inline for loop, and I'm going to lemmatize each and every token, right? So for that, first let me write the statement of the for loop, which will be something like this: for token in tokens, for token in tokens, this will be the statement. And what are we going to do in this, right? That is the next step. So what do we want in this, right? We want to perform the lemmatization, right? So for that, we have already made the lemmatizer. So for that, let's write WN lemmatizer, right? Dot lemmatize, which is a function of this. So its spelling cannot be changed, right? And in that, we will write the token. So each token will be lemmatized with the help of this function. So this is the first step, right? And this step will make sure that we are performing the lemmatization. What is the next step? After this, the next step is to actually, let's complete this word. Okay, so the next step is to remove the punctuation from the complete paragraph, right? And after that, we will process the complete document. So these are all the steps. So for punctuation removal, we will also use a inline for loop. Let me write it. So punctuational removal PR is equal to, we will make a dictionary in which we will get the unique values of all the punctuations and unique IDs. And for unique IDs, the command that we are going to use is ORD, right? And it is for unique IDs. So let's write punctuation here and comma none. So this is the way of getting unique IDs out of that, right? Now, how many times do we want to remove this punctuation? So for punctuation in the complete string, right? So for that, we will write for punctuation in string dot punctuation, right? So we are going to convert the complete of this string and delete all of its punctuation and save it into PR, right? So this is the process of deleting all the punctuation. And what is the next step? The next step is actually to give a data into this whole system and perform lemmatization as well as deleting the punctuation. So how do we want to do this? We want to do it like this. Let me show you. So this is our data, right? All of this. Let me see where it is. Yeah. So this is our data, all of this. What we want to do is we want to see if this is a document and it comes, right? So the first thing that we need to do is we need to convert it into lower format, right? And after that, what we need to do is we need to translate it by removing all the punctuations, right? So the first thing is to convert it into lower format, and that lower format should be done after punctuation is removed. And on that lower formatted punctuation removed document, we will perform tokenization. Let me repeat it. We will perform tokenization on the document which is in lower format as well as punctuation removed. So let me write a function for that. Let's write get processed underscore text, and here I'll write document. After that, what I need to do is I need to return something. So I'll return perform lemmatization on what? Let me write it now. So lemmatization will be performed on tokenized document. So for that I need to write nltk dot word underscore tokenize. So we need to perform tokenized lemmatization. However, this tokenization should be done on a document which is already in the lower format, right? So these are all the steps that we have actually covered. So document will be in lower format and it will be tokenized, then lemmatization will be performed. However, there is something else that we need to first of all remove the punctuation, then make it lower. So for that, let's use the function translate, and here I am going to write for punctuation removal I'll write PR. So this is the complete way. The first thing is punctuation will be removed. After that, it will be converted into lower format, and into that document we will be later able to perform tokenization and then perform lemmatization. So these are all the steps that we are going to follow. There we go. So this was the most important part to understand. Now if you have been able to understand this, now let's make up a greeting mechanism. For example, we have greeting inputs. So let's write the inputs are something like hey, hello, and these things. Let's take a few. So let's say only 2 of them. We can only start with hey and hello. Make sure that these are small words, right? And let's say that these are the let's increase these. I have a few of more of them. Let me copy them. Yeah, so this one, and let's say that now the greeting underscore responses. What are these responses? For that, let's write in square brackets a few of them, like hey, how is you, and these things. So let me take them as well. There we go. Now that we have made the greeting input and greeting responses, the next step is to make a function, right? So the function name will be generate greeting response. So let's do that. Let's write generate underscore greeting underscore response, right? And in that, let's write greeting as an input into this function, And what will this function do? This function will basically split down this greeting that we have taken as an input and see how many tokens are present in that. So for that we will write for token in greeting under dot split, right? And what should happen after that? So in this, what we will do is we will actually check out if in the greeting inputs we have tokens in lower formats, right? Because all of these are in lower format, right? And if these are available in lower format, then we will choose randomly one response from here and just print it out, right? So if token in lower format, right, dot lower is available in greeting underscore inputs, what should happen then? Let me write it. Then it should return that randomly we should choose random dot choice is the command, and from the greeting responses. Let's run this and let's move forward. What is the next step? The next step is actually to make out the generate response function, right? So for generating response we would need a few vectorizations as well as a similarity function. So for vectorization we are going to use tf-idf vectorizer, and for similarity we are going to use cosine similarity. So let's do that. From scalar dot feature underscore extraction, right? So feature underscore extraction, what are we going to do? Dot text, what do we want to import from here? tf-idf vectorizer. So let's write tf-idf vectorizer. After that, the second thing that we need to input is the cosine similarity, which is available in skitlearn matrix dot pairwise. So let's do that. From skitlearn dot matrix dot pairwise, what do we want to do? We want to import cosine similarity. There we go, just like that. Okay, so now that we have made this, what is the next step? The next step is actually to make and generate a function, response function. For that we are going to use this tf-idf vectorizer as well as this cosine similarity, right? So first let's give it a name. The name is define generate underscore response, and in that we are going to input the user. So user underscore input will be in this, right? And the first response should be a null one. So for that let's write bot response is equal to null, and after that what we need to do is we need to add all of the input that is given by the user into the data sentences, right? So let's see the word the for data sentence was scn. So let's copy that. Let's come below and say scn dot append, and here we will append user input. So these sentences will be added into the sentence list. After that what we need to do is we need to develop a vectorizer and check out the similarity, right? So for vectorizer we are going to use the tf-idf vectorizer. So let's do this. For word vectorizer is equal to tf-idf vectorizer, and in that I'm going to say that tokenizer, which is the tokenizer that we are going to use. This is the tokenizer, so, right? So let's actually write tokenizer to be used later for our own information, right? So we are going to use this tokenizer. So let's do that by writing tokenizer is equal to get underscore processed, right, underscore text. So document will go inside this and lemmatization will be performed, right, in this way that we discussed right here. Okay, so what is the next step? The next step is to actually give it some stop words. So I'll give it only one stop word, which is English. So stop words is equal to English. Okay, so this is the word vectorizer. Now what we need to do is we need to convert all of our sentences into word vectors. So for that, let's write word underscore vectors is equal to word vectorizer, right? So this is the vectorizer that we are using, word vectorizer dot fit underscore transform. And what do we want to transform with this? The sentences, right? So with this command, what we will have is we will have all of the word vector of these sentences, right? And after getting all of these word vectors for each sentence, what do we want to do? We want to see what are the similar words, right? And what are the similar sentences, right? So for that, the first thing that we need to do is we need to see what are the similar vectors out of these word vectors, right? So what I'm going to do is I'm going to perform a cosine similarity in which we will take two matrices. One will be shifted by one value, right? And in that way we should be able to see all of the cosine similarity values. So for that, let's write similar vector underscore values is equal to cosine, after that underscore similarity, after that I'll tell it to enter all word vectors, right, and shift them with one position. So let's write -1 and compare them with simply all word vectors. So there we go, right? And what should happen after this? After this we should have the similar sentence number, right? That how many sentences are similar, and we are going to do that by performing argumented sorting between two matrices. So let's do that. So similar underscore sentence underscore number is equal to similar underscore vector underscore values, the one that we have developed above, dot arg sort, and after that we are going to say it to take 0 and -2 index, right? Now we have the similar sentence number right here, right? And after that what we need to do is we need to have a matched vector as well, right? So for that what we need to do is we need to actually flatten these values, right? So after flattening these values we will sort them out and pick one of the value which will be matched vector, right? So let's do that. So matched underscore vector is equal to similar underscore vector underscore values dot flatten, and here after that I'll tell it that matched underscore vector dot sort should perform the sorting, and after that there is only one step which is left, and that is vector underscore matched will be equal to the -2 index of matched vector. So matched underscore vector and -2 index. So after this, what we'll have here is we will have a matched vector available, right? And what is the reason for that? So if this vector matched, right, the value of this is equal to 0, then bot response will be added into something like I'm sorry, I could not understand you, or anything like that, right? And if this vector matched is not equal to 0, actually it is something else, then we will add the bot response with some sentences with similar sentence number, right? This one, right? So if this matched vector is 0, we will not use this similar sentence number, and if this matched vector is 0, then we will not use it, and if it is not 0, then we will use it, right? So that it only happens if there is a match available, and then we will have a similar sentence number right there. Okay, so for that, what we need to do first is we need to write a if statement. So let's write if vector underscore matched is equal to 0, then bot underscore response is equal to bot underscore response, right? After that, plus something like I am sorry, I don't understand, right? And after that, we will have our return of bot response as well. So return bot underscore response, and later in the else statement we should have something opposite than this, right? So for that, we will write bot response is equal to bot underscore response plus sentences. For sentences, we will use scn, right? And after that, we'll say that enter the similar sentence number into this, like this, right? And then we will return with the bot underscore response. So this is how it will go, right? So this is the complete function. With the help of this, we can generate responses. Let me repeat it. So the first thing that we did was we attached all of the user inputs with the sentences. Later we developed a word vectorizer, right? And with the help of that, we developed word vectors from the sentences, and then we developed a similarity matrix, and after that we checked what are the matched vectors that are available. So if there is no matched vector, then we'll say that we do not understand what you are saying, right? And if there are matched vectors available, then we will say that okay, so this is our response to whatever you are saying, right? So let's run this, and now the time of epiphany is here, right? Now what we will do is we will actually check out our bot functionality. Okay, so for that, the first thing that we need to do is we need to take on a flag, right? So let's name the flag as continue flag, and let's say that it is true in the start. After that, we should print out something like hello, I am as you know, the page that we are using is data science. So I'll write something like I am a data science bot shoot your question, right? So this is the thing that your bot has asked you to do, right? Now what do we do? we say that if this continue flag remains true, then the discussion should continue, right? If this continue flag remains true, then the discussion should continue. So for that, we'll use a while loop in the start, in which we are going to see that if the continue underscore flag is equal to true, then the discussion will keep on going, right? And let's say that the human says something like an input, we'll take it from the user, right? And after that, what is the next step? The next step is to convert this input into lower format. Let me repeat it. The next step is to convert this input into lower format. So human is equal to human dot lower, right? That's how we'll do this, right? Okay, so now there is a chance that human is saying something like bye, right? So what if human says bye? So that way we will have to say goodbye to it, right? And there is a chance that it does not say bye, right? Then we will have a complete architecture of our bot. So if we have a statement such as this, if human does not say bye, right? So if the human does not say bye, what can he next say? Let's see. The human can say some things like thank you very much, or some things like that, right? So even if the human says this, then that is also an end of discussion, right? So let's suppose if human says something like thanks, or something like thank you, or human says something like thank you. So if these are the things that are said, then it should the human should not continue the discussion, right? And the chatbot should say you are most welcome, or something like that. So before doing that, what we need to do is we need to make sure that the continue flag is false, so that we will get out of the while loop, sorry. So here the continue underscore flag will become false, right? So this is the first thing that will be done. And then we'll print out something like most welcome from DS bot, right? Something like that. So we'll have this, right? And after that, what we'll do is we will have a chance where the human is not saying thanks or anything like that, and he is saying something other than thanks, right? It is not bye, sorry, it is not bye, and it is not thanks. And in that way we should be able to generate something, right? So that's why I am writing this else. Okay, so now there are also two chances, right? So if the generate greeting response, and this one is not equal to none, right, then there should be one response. And if this is equal to none, then we should do a greeting, right? So what I mean to do here is, in this else we'll tell it if the human is asking for greeting or not, right? So first let's say if human is not asking for greeting. So if generate underscore greeting underscore response of the human, right, of the human is not equal to none, what should happen then? Then we should print out something like DS bot, right? And after that we should add some response into it, so it will do a greeting right here. So generate greeting response, right? So there can be two responses. One is for this part, and one is for this part. So it will be done when there is a greeting, it will be done when there is no greeting and there is simple generation, right? So generate greeting response on human text. Okay, this is if, and what should be the else, right? So else is of course very much clear now. We have to use this function to generate the regular response. So this else is the only thing that is working actually as the response of the bot. So let's write dsbot, and here we know one thing, that whatever we enter into this will be added into sentences as well. So that's why what we need to do is we need to first use the generate response function. So let's do that. So generate underscore response, right? And we will enter human value into this, and after doing the generate response, then we should remove it from the sentences as well. So sentence dot remove, and here I'll say human. There we go. Now that we have done everything, there is only one thing that is left, and that thing is what happens when human says bye, right? So which was the first if, this one. So its else should be very much simple. The first thing is to make the flag false. So continue flag is equal to false is the first thing, and the second thing is to print out something like ds bot says goodbye. So let's run this. So shoot your question. Let's say that we can ask it some question. So what question can we ask it, right? Let's find a question. Actually, let's just see this Wikipedia page. So of course this is the corpus. So who is a data scientist, right? Or what is data science? So what is data science? Yeah, there is some error. I have to write e here in token.lore. Let me do that and run it again. So now that I have done this, let's actually say something like data scientist. Okay, so it is saying that data scientist is someone who creates programming code and combines it with statistical knowledge to create insights from the data, right? So these are the things that we can use and showcase in this, right? And data, I have asked it about data scientist. Let's also ask it about data science. So the bot is responding with what is data science. Okay, so let's do that. Let's also try something like relationship to statistics. So like this, right? So let's come here and let's say that the first thing is the DS bot is saying that the describe data science as an applied field growing out of traditional statistics. So this is the answer to this question when we asked it what is data science, right? So there we go. This is how we can develop a machine learning based bot, right? And we can actually make a lot of bots with the help of this, right? And in the later videos as well, I'm going to develop a few more advanced bots where I'll be using the same terminologies and making a machine learning bot that works better than this one, right? So maybe I'll be changing the corpus a little bit, right? So by changing the corpus and by getting more data into it, it is actually only on one web page. So what I want is a bot maybe with a complete functionality, right? So we'll do that in some next project. So for that, for today, it is goodbye. This is Shahzaib Hamid, and this project was a beautifully conducted web scraping chatbot with the help of NLTK, beautiful soap, as well as request library in Python.